Hi, my name is Daniel Monforti. I'm an application engineer with Regal Technologies, and today I'll be going over a couple simple tests you can perform on some solar panels with an electronic load. These tests will include going over manufacturer specifications along with determining the maximum power output of your solar panel or solar panels. To double check some of the specs that were provided with our solar panels, we've hooked up to our electronic load and we're going to check our open circuit voltage. And here we can see we're getting 20.9 volts. And then we can also check our short circuit current in this configuration. To do this, I'm just going to turn on the electronic load. And as we can see, we're getting 3.7, 3.8 amps being generated from our two solar panels. Based on our results in the previous tests, we can see that our solar panels did not meet the open circuit voltage and short circuit current specification. For our next test, what we'll be looking for is determining the maximum power that our solar panels can produce in parallel. So to do this, I've already preset up in list mode a series of voltage steps. It's about half a voltage offset from 0 to 22 volts in 45 steps, and they're going to last about a second. Now, in order to save the data, what I'm going to do is I've already got a flash drive pushed into the front of the instrument. I'm going to hit next over here, which brings me to the next page. Hit record. Once the record is started, it'll indicate up here. Then I can go back. And what I can do at this point is I can turn on the load and then hit the transient function. And as we'll see in blue, we'll see it move over after each second where it's taking a measurement and it's going to record the amplitude, voltage, and our power being drained at the time from our solar panels. And we'll just go through and we'll let this test run, and after that we'll examine it in Excel to determine basically our maximum power that the two solar panels can produce in parallel. I took the data that I captured during the previous test and graphed it by using Excel to create a current versus voltage curve on the left and then a power versus voltage curve on the right. Based on the results in our test, I can say that the maximum power of the solar panels produced is 47.2 watts, which occurred at 12 volts. For our final test, we'll be more or less duplicating what we already did by using the front panel of the load, but this time we'll be using the ultraload software. So to do this, just like before, I'm going to go into list mode. And I've already configured the software so it's communicating with the load. And I'm basically, at this point, going to go into constant voltage mode. Then I can choose my start voltage. For this, I'm going with 0. I can choose my stop voltage. I'm going to go with 22 volts, just like before. Then I'm going to choose my step amount. I can go with 1 volt or I can go with half a volt, which was equivalent to what I did before. I can go with time. I'm going to actually choose half a second just to speed things up a little bit. And at this point I can hit create. And this will create our whole table down here with our values of 0, half a volt, 1 volt, and then our time at all half a second. And now in order to send this information to the load, I have to hit configure. And now at this point I can turn it on and then hit the transient button just like before. And we'll see over here the voltage drop down to 0 and our current rapidly go up, and we'll also see the values over here in the screen as well. And we'll see in purple the actual power reading being increased, and we'll see it cap out, which it's capping out right there, and it's going to trail off following our current drop. And this will actually give us our maximum power down here in blue of, it looks like, 44 watts. Our DL3000 series electronic load makes a great solar panel testing instrument to help with verifying manufacturer specifications and determining the maximum power that the solar panels can produce.